Welcome to this Sahara 4 exercise. In this exercise, we will create new allocation factors to distribute the production per layer over time for all the wells in our project. Um, in a previous exercise, in exercise number 20, we did import the allocation factors externally to divide the injection in the different layers that we have in the project. But now the idea is to create new allocation factors for the production side. So we will apply those allocation factors to all the producers. Now we will go to our Sora project, and once here we will select tools, tools allocation factor, and here we will generate new allocation factors. Here we are going to select the phases where we want to apply the allocation factors. As we can see, oil and water is already selected. Those will be the phases where we want to apply it because those are the production phases. So we will apply it here. We will select all the wells. The allocation factors that will be generated will be stored here in the default the default alternative, and here we have the different distribution methods. We have PLT that is going to come from a log. In this case, we can import this one as a last file and then apply it to create the allocation factors. In the case that we already imported the production on the layer level and we want to use to create the allocation factors based on this production data, we can do it with this option here. And here we have scatter data and petrophysical data. The difference is that scatter data is going to be a well layer data, same as petrophysical data, but it's going to change over time. Those are going to be values that are going to be associated to the layers and the wells, to a combination of well and layer, but that is also going to be tied or is going to be connected to the time. So if you want to calculate the allocation factors based on a parameter that changes over time, you can do it by creating a variable and selecting scatter data. Petrophysical data instead is going to be the combination of a well and a layer value, but that doesn't change over time. So in this case, the calculation is going to be based on the sum of of this petrophysical data in all the layers, in all the open layers at that time in a well. So if we later we cement, or if we close, we do a squeeze and we close some layers, or we open new layers, a new calculation will be done for the allocation factor. So even if the petrophysical data doesn't really change over time, the calculation, the allocation factor is going to change because it is going to consider the layers that are open or closed at each different date. So in this case, we will select petrophysical data and we will, based on net thickness, we are going to do the calculation based on net thickness in this case. Yes, correct, in net thickness. So now we select it and now we can calculate it with this button here. And now we have this report where we can see that it was calculated for all these wells. There are four inconsistencies here because the well status doesn't match. This is because these four wells were never producers. They were drilled as injectors and they remain as injectors all the time. So they will not be. I mean, we are going to have this inconsistency report here, but it's because of the status that is never a producer. So that's okay. We don't care about that. The rest of the production has their allocation factor calculated. So before we apply them, we can check on them. If we go here to allocation factors, um, tools, allocation factors, and here we can go to edition, and here we can see that, for example, for the well D1, we have this undefined status first when the well is actually drilled here in 1978. We have all these layers open, and we can see that these two layers are closed because they are closed based on the layer status as imported in one of the first exercises. And now the amount of production that goes to each different layer that is open is going to depend on the net thickness. The more net thickness the layer has, the more production will be allocated to this layer. Then afterwards, in this later date, we have workover here where we open the layer 30 and 31, and also the 35 and the 44, and now a new calculation has been done and new allocation factors have been calculated for this new stage of the well where we have all these layers open. Now the allocation factor is going to distribute the total production based on the relative net thickness of each layer relative to the total. So we can see how much of that percentage is distributed between the different layers, and we can see that the total in both cases is going to sum 100%. And also we have a plot here that is going to show the different with different colors that will be based on the layer color in edit layer static data is going to show different colors for the different layers and how this is distributed over time. We can see that the different wells will have different set of layers, and also it will in the same window here we can review at the same time the allocation factors that have been calculated when the wells were producers, and if the well was converted afterwards we can see the imported allocation factors for the water injected, so we can see how the distribution has been done over time. So now we will close this and we will apply these allocation factors by going to tools, allocation factors, apply. And here we have the alternative default because here's where we store the allocation factors that we calculated. Here we will select monthly productions, and here we are going to apply the allocation factor to the history scenario. Always remember that when you select a scenario here, you are going to this is the scenario where the calculation is going to be performed. So the production, the total well production from history will be used to divide it is going to be divided by the allocation factors, and also the new production in the layer level will also be stored in the same scenario. So you are going to have the information where the calculation is based and the result are going to be in the same scenario that is the one that is going to be selected here. And here we have the subphase, and you can decide which date to start the calculation, and the end of the calculation as well. Here you can define it as the start of the secondary recovery. In case that you have a different criteria for the secondary recovery, for the division of the secondary recovery, you can select this option to stop the calculation when the first flow element appears in each different well and layer. But here we will do it for the whole history of the project. So we will select all the wells, and now we will apply it to water and oil, and we will apply the allocation factors stored here in default. So now we apply it, and now we will have a new report that will show us that we applied correctly to most of the wells. We have a couple of inconsistencies here, but we can see that those are the same wells that weren't producers before. So we will click OK here and now close. And then now you can open your production window. Here we will create a new template and we will check our production over time. For that, no, I will remove this axis. And now I will select new variables. Now we will see that if we select monthly productions history oil, we have the information at the object level. This is the original oil that we imported back in the importation of production exercise, and now the new production that is at the layer level. So now we will use this layer information for oil and for water. I think it's better if we just plot it as liquid and do it like this. So now we will select a well and see if we have any production. I will auto configure here, and we can see the production of the layer selected, and we can see that with different layers we have different production. What we can do here, a plot that is quite useful if you want to check this and compare it to the total production of the well. We will change this to dash, and we change this one to black and dash as well, and we will add at the same time the production at the total well level. So object total calendar day, and also history liquid object total calendar day. And now we will increase the thickness of the well level, and we will do it as well for the liquid, and here like that. Now you can see that you will be plotting the total oil and liquid for the well in this with higher thickness like this, in like a bolded line. And here you will do it with a dashed line for the layers. So if you want to check, for example, just oil, you can do it like this. So now you have a quick preview of how much oil is being produced at the total well level and how much is being produced in the layer. So we can see that how it changes over time. I will just freeze the scale, fix the scale, so we can see only the change on the layer level. So now we have a better view of how much is being produced in each different layer. So if I select all the layers, we will have the same curve here. I'm going to hide this for a second, and you can see that we have the total is 100%. So that's a way also to test that the allocation factors are correct. And if you select a layer that doesn't have any production, you will only have the curve at the object level. So that will be everything for this tutorial. We have created new allocation factors based on petrophysical data of the wells, and now we have our production per layer defined based on this petrophysical data. So thank you for watching and have a great day.